Junk has an unavoidable role in our daily lives, from the packaging of consumer products to outdated appliances. In 2013 alone, Singapore generated almost 1.5 million metric tons of ferrous metal scrap. However, this waste has the potential to be transformed into a valuable resource. With a recycling rate of 97% for ferrous metal in 2013, the recycling industry plays a crucial role in conserving our planet's resources. In this video, we will delve into the world of scrap metal and discover how it can be transformed from unwanted junk into a valuable resource. Join us as we investigate the turning of one man's trash into another man's treasure.
But why should we bother recycling all of the metal items we no longer need? By not recycling metal, we are not only filling landfills and placing a strain on our environment, but we are also wasting important resources. In fact, recycling metal needs far less energy than extracting new metals. Recycling aluminium, for instance, consumes 95% less energy than mining it. Every time we recycle metal, we not only help the environment, but also contribute to a more sustainable future for generations to come.
Today, we'll look at magnetic separation. Magnetic separation is one of the earliest physical processes for separating minerals, dating as far back as the early 1900s in the mining industry. It is a physical separation method that makes use of the differences in the magnetism of metals in a mixture to separate them. This is accomplished using a wide range of separators. Drum magnets and overhead belt magnets are the most commonly used. The scrap is transported on a conveyor belt and comes into contact with the fields of a strong neodymium magnet. It attracts the ferrous metals, causing them to stick to the conveyor belt, which is then removed and processed further. Non-ferrous particles travel freely through the magnetic field and are collected in a separate collection area. However, debris that may be mixed in, such as rubber and plastic, necessitates additional processing.
For a method to have stood the test of time for over a century, magnetic separation had to be more advantageous compared to other methods. These advantages include its efficiency and effectiveness. Magnetic separation is fast and efficient in separating ferrous metals from other metal components in a mixture. It can effectively separate even small pieces of ferrous metal, making it a suitable choice for processing large quantities of scrap metal quickly. What truly shows this method's advantages is the fact that this method is not only used in the scrap metal industry, but is also used in a variety of metal recycling applications, including the processing of electronic waste.
However, with every advantage comes a disadvantage. For example, it is only effective in separating ferrous metals, requiring further separation procedures to separate impurities like plastic and rubber from non-ferrous materials, increasing the cost of the recycling process. Furthermore, as compared to alternative separation processes such as air classification, magnetic separation can be an expensive operation.
So, where else does this separation technology come into play? As stated previously, magnetic separation is also used in the mining industry to separate magnetic materials such as magnetite from non-magnetic materials to concentrate valuable minerals and increase the efficiency of mining operations, as well as in the electronic recycling process to separate magnetic and non-magnetic metals when large items such as computer monitors and televisions are disassembled. This procedure can be done several times to further separate various metals such as aluminum, copper, and precious metals. Aside from the obvious applications, magnetic separation is also utilized in the food and beverage sector to separate harmful impurities like metal pieces, black stones, and mud balls from fruit products, improving the quality and safety of the food we eat.
And of course, over the century that magnetic separation has been in use, alternatives have been tried and tested with their own advantages and disadvantages each. For example, eddy current separation uses a high-frequency magnetic field to induce an electric current in conductive materials such as aluminium and copper, causing them to repel themselves from the magnetic field. However, this is most effective when magnetic separation is used to sort scrap into ferrous and non-ferrous materials, and only then is eddy current separation used to sort them into metals and non-metals. Another alternative is air classification, where lightweight materials such as small metal pieces, plastics, rubbers, and foams are fed through a column of blowing air to separate them. Heavier metals are collected at the bottom, while other materials are driven through various feeds.
In conclusion, magnetic separation has been proven to be a valuable tool in the world of scrap metal recycling. It has stood the test of time for over a century, demonstrating its value and reliability time and time again. Through its ability to effectively separate different types of metal, its simplicity and affordability, magnetic separation has made it possible for us to turn what was once considered waste into a valuable resource. By choosing to use magnetic separation, we are not only making a positive impact on the environment, but also contributing to a more sustainable future for generations to come. So let's embrace this innovative technology and take a step towards a world where waste is no longer seen as just junk, but instead a valuable resource waiting to be transformed.